In this last video, we're going to learn how to use the fraction 1/2 as a benchmark. So let's read the first question. Each of the fractions below are equivalent to 1/2. Write the numeric representation in terms of the number of equally shaded pieces below each image. Note, the dashed lines represent a unit fraction that has been cut in half. So let's look at the first picture. This unit has been cut into 4 equal pieces and 2 pieces are shaded, so it represents 2/4. Let's skip to this one and we'll go back to the red dashed lines. This has 6 pieces and 3 are shaded, so this is equivalent to 3/6. And here we have 4 out of 8 pieces shaded. Now going back to this image, notice that this shaded part and this unshaded part are a unit fraction in this circle. So this equals 1/5. There's 1, 2, 3, 4, 5 equal pieces. And this one has been cut in half, this 1/5, so that we can see 1/2 of the unit when the whole is cut into 5 equal pieces. So let's write the denominator of 5. And now the number of shaded pieces are 1, 2, and 1/2. Okay, so we're going to write a fraction in a fraction. Okay, but don't let this bother you. We're just going to use this to help us with this benchmarking idea. And looking at this one, we have 1, 2, 3, 4, 5, 6, and these two together are 1 unit fraction, or 1/7. So we have 7 equal pieces, and 1, 2, 3.5 are shaded. So let's stop for a second and look at patterns. So notice we're increasing by 1 piece as we move from left to right, and the numerators are increasing by 1/2 as we move from left to right. And that's because we're taking 1/2 of the denominator. So if the denominators are increasing by 1, half of that is going to increase by 1/2. So another way to think about this that's going to be useful is if you want to know the equivalent fraction to 1/2 with any denominator, you can just divide the denominator by 2. So notice 4 divided by 2 is 2. 5 divided by 2 would be 2.5. 6 divided by 2 equals 3. 7 divided by 2 equals 3.5. 8 divided by 2 equals 4. Now let's see how we can use this to compare fractions. So in part B, using the images above, so I've placed the images right up here for a reference, determine whether the following fractions are less than, equal to, or greater than 1/2 using these symbols. So first we're going to compare 1/4 and 1/2. And we've already compared these numbers based on the numerators being equal, and this has a bigger denominator, so it's smaller. But let's use 1/2 to compare it. So since this has a denominator of 4, I'm going to look here, and 2/4 is equal to 1/2. So 1/4 would be less because it would be only one of these pieces. So this is the less than symbol, and remember, basically you want the pointy part will be pointing towards the smaller number, and the open part will be pointing towards the bigger number. Here we have 3, 6, and 1/2. We want to compare them. Well, I'm looking at the denominator of 6, and if we go to this image, notice 3, 6 is exactly equal to 1/2. So these are equivalent. Next, we'll compare 4/7 with 1/2. So the denominator is 7, so I'm going to look at this image. So 1/2 of 7 would be 3/2 shaded, 3/2 sevens shaded. And notice 4 is bigger than 3/2, so we'd also include this little piece. So we know that 4/7 is greater than 1/2. Next we have 2/5, and we're comparing that to 1/2. Well, looking up at the unit cut into 5 pieces, 2.5 is equal to 1/2, 2.5 fifths. So since we only have 2, that would just be these two pieces, it would be less than 1/2. Comparing 3/7 to 1/2, well, here's the sevenths. So 1, 2, 3 would not complete 1/2, it would be less than 1/2. And finally 4/8 and 1/2. Well, if we go up to the image with a denominator of 8, we see that 4/8 is equal to 1/2. Now in this last part, we're going to use the information from part B to compare the fractions. So let's think about the idea that we're going to use here. So, say you know that Bob has less than half a cookie, and John has more than half a cookie. So in this situation, we don't know exactly how much Bob has or exactly how much John has in terms of what part of a cookie, but we can say something about the relationship between how much of a cookie Bob has and John has. So drawing a little picture, I'll use a number line here, 0, 1, and 1/2. The amount that Bob has is less than half a cookie, so it's here somewhere. This would be Bob. The amount that John has is more than half a cookie, so it would be somewhere in here. So notice that the amount that John has must be greater than the amount that Bob has. So John has more. So this is the idea we're going to use in this last example. So let's compare these fractions. So we want to compare 1/4 and 3/6. Well, here we saw that 1/4 is less than 1/2, and here we saw that 3/6 equals 1/2. So I'm just going to put little symbols above them. Let's say less than 1/2, and this is equal to 1/2. Well, that means 1/4 must be less than 3/6. Let's look at the next one. 2/5, well, we saw that that's less than 1/2, so I'll put an L for less than. We saw that 4/7 is greater than 1/2. Well, that means 2/5 must be less than 4/7. And finally, we saw that 4/8 equals 1/2, so I'll put an E above this. 3/7 is less than 1/2, so that means 3/7 will be less than 4/8, or 4/8 is greater than 3/7. So now let's just summarize some of the information we've used here. First, give an example when you cannot use 1/2 as a benchmark to order fractions. So we can't always use 1/2. And notice there was something specific with the Bob and John situation. Bob had less than 1/2 and John had more than 1/2 of a cookie. So say Tom has less than 1/2 and Sarah has less than 1/2. If we know this information, this is useful information, but we can't compare how much Tom has to how much Sarah has, because all we know is that both Tom and Sarah's amount of cookies lie in here. So we don't know which one is to the right and which one is to the left. So this is one example, and let's just pick specific numbers. So let's say Tom has, I'm going to pick a denominator, 12. And I'll say 5/12 because I know 5 is less than half of 6. So this will be less than half. and 18 for Sarah, and half of 18 is 9, so something less than a half might be 7/18. So for these two numbers, we couldn't use 1/2 as a benchmark because both of these are less than 1/2. Okay, so this is useful when you could say one is larger and one is smaller. So similarly, if they were both greater than 1/2, that wouldn't give us enough information. Now develop a general rule for ordering fractions using 1/2 as a benchmark. So let's think about the process that we went through. So compare each of the given numbers to 1/2. Then, if the two numbers are different relative to 1/2, compare them using 1/2 as a benchmark. And in particular, we mean the number less than 1/2. I'm just going to change colors for a second. Is less than the number greater than 1/2. Okay, so notice I changed colors here because we were saying less than and greater than a lot, and I wanted you to see how we're comparing them. So we have two numbers. They're different relative to 1/2, meaning one is less than or equal to and one is greater than or equal to. So then the number that's less than 1/2 must be less than the number greater than 1/2. So at first this may take a little time to adjust to using 1/2 as a benchmark, but it's incredibly useful to be able to make these distinctions without having to rewrite everything with common denominators.